Hi, and welcome to questions on polymerization in alkenes. So our first question we have here is wanting us to write a balanced equation for formation of the polymer that is mentioned above. So 2-chloropropene to poly-2-chloropropene. Now, hopefully we're able to draw. Now, it hasn't given us any sort of indication of what it might look like, but hopefully we know what 2-chloropropene looks like. So just start off by drawing propene and then adding a chloro group with the second position. Making sure we have that N at the beginning, showing that we have multiple units of these. Now going from an alkene, we're going to lose that double bond. We're going to straighten up our bonds, make sure the bonds go through the square brackets, and we have that N on the bottom right of it as well. Make sure you've got them square brackets there, make sure that double bond is no longer there, and those bonds to the left and right go beyond the square brackets. Then, once we're disposing it by combustion, a particular problem disposal of this by combustion is the fact that we're going to get the formation of hydrochloric acid or some chlorine being produced. Okay, and question 2. Now, these questions now aren't so much to do with polymerization in alkenes. They're more questions to do with just reactions of alkenes and then getting on some mechanisms as well. So it's a bit more sort of organic synthesis and a bit more organic chemistry, so it's not quite polymerization, but I thought it'd be good to have these questions in here just as a bit of practice. So we have compound L, reaction 1 with HBr, so we've got an addition reaction there. We'll look at the mechanism of that in the next question, so we won't say too much about that right now. And what we should have is our product there. Again, how that's actually gone on in a little bit. And then if we have that product there and we react it with excess NH3, then we should form the same thing we did, but without the bromine there, we'd have an NH2 there. There is also an addition to this where you could have the O- with the NH4+. If the NH4+ wasn't there, they would still give you credit for that one. Now again, I've just broken this up over two different sections to fit it all in. Again, we're starting with that product from reaction 1. If we then have sodium hydroxide, what would we get? And then if we then had something with H+, with this is the product that we'd form on the left hand side there. So that sort of indication, maybe hopefully a bit of a help as to what we might get, might inform our decision what we might be getting. So for these we have 1 mark for each, 3 marks is 1 mark for each structure that you get correct. Now hopefully we'd have something along those lines there. So we'd have an OH where the Br would be, and then we'd have an O-, and then if Na+ is there, then that is fine as well. But if you have just the O-, that's accepted also. Okay, and now for this particular reaction, so we mentioned the reaction mechanism we're going to go into, because the question here now is asking us to have this reaction mechanism with your dipoles and also be able to name it as well. Which I've just mentioned before as well, 4 marks. So hopefully we know that within our HBr molecule, we have the hydrogen is delta positive, the bromine is delta negative. Now that arrow needs to make sure it starts from the double bond. Make sure that is clear as day. Curly arrow pointing to the delta positive hydrogen. And then within that, we have the bond, the electrons in the bond from the H and the Br going to the bromine. Those two things need to make sure they're there to start with. Once we have that, we form our intermediate. Now, that bromine is going to come back in now. Again, make sure your curly arrows start at the bromine, so probably best from the lone pair of electrons. Not been shown in this one here, but always good to show those lone pair of electrons on the bromine that also has the negative charge, clearly pointing to that positive carbon that's there. And type of reaction is electrophilic addition. So 3 marks from the mechanism with your curly arrows and your charges, and then you get your 4th and final mark from the name of the mechanism. Okay, so that will do us for today on polymerization in alkenes. See you next time.